In this session, we're going to talk about breaking programs into logical chunks called modules. The term that you'll hear associated with breaking a task into modules is called modularity, and a good program is a modular program. So the definition I have here is from Microsoft, and it indicates that we're looking at a system and we're dividing it into a set of functional units. And this is the key word right here, functional units. Each one of those units has a very specific task to perform, and it does one task. So one is a key word here. If we look at our diagram, we have our main task, and this is the one that would control all the other modules. Then we have our series of subtasks, subtask 1, 2, all the way up to subtask n, and in some languages, C included, these are called functions. You might hear them referred to as procedures or subroutines, and sometimes even modules, but in C, it's functions. So the job of the main module is to control the rest and to call upon the other subtasks or other functions when that particular task needs to be completed. Every program has its own unique set of modules or functions, but generally we can break them into three groups. The first are input functions. So these are ones that, as we can see up here, would get input from a user, would read input from files, or possibly get information from external devices such as sensors. The second type of function that we're going to have are ones that process information. So we might be doing some calculations with the user input values. We might be analyzing some data, or we might be figuring out how a system is behaving. The last type of function that we'll see in a program is an output function. So here we might be displaying results, we might be tabulating the results of our analysis, or we might physically be controlling a system. It doesn't matter what type of a system, you're generally going to have each of these three types of modules. In order to make your code maintainable and readable by others, all the functions that you include in your program should be named with a verb followed by a noun. So let's take a look at some of our input functions. We might have a function called getFahrenheit. So this would imply we're going to get something from the user, and it's going to be something that represents a Fahrenheit temperature. If we have read samples, read usually means we're coming from a database of some kind, so either maybe a file, maybe a set of built-in data, and we're getting some information that represents samples. And then check sensor would indicate we're going out to check a physical device to see what its state is, in this case, a sensor. If we look at some of our processing functions, we can see convert to would be our verb, and Celsius would be our noun. So convert to means we're going to take this Fahrenheit value and we're going to convert it to Celsius. If we look at our samples, find average. So we're going to read them here and then we're going to find the average. Or maybe we're going to find the maximum value. And then finally with our sensors, we read them over here. Now we're going to reverse the direction. So we're taking a reading, and because of a sensor value, we're now going to reverse the direction of maybe a motor drive. If we look at our output functions, we can see display. So here we're going to show the temperatures, our Fahrenheit and our Celsius. Display results. We've read some samples, we've done some calculations, now we're going to display those results. And finally, in our sensor program, we checked a sensor, we did something, and here we're going to flash some kind of an indicator for the user. Now when we start talking about writing functions for our C programs, we need to consider three main things: being able to write the function itself, being able to prototype it, and being able to actually call it. We're going to talk about these three elements in the next session.